Lecture series of C programming. In today's class, we are going to see about what are all the program development life cycle and what is the problem solving techniques, then types of problem solving techniques. First, we will see that what is the program development life cycle. So the development life cycle is just like the software development life cycle. The first step is we have to analyze the program, and after analyzing we are going to define the problem. So first they are giving the some problem statement. So based upon the problem statement, we have to analyze what is the definition of the problem. That is the first step. Second step is a task analysis. So what is the task means, how do you going to implement that defined problem. That is a task analysis. That is the second stage. And the third one is the designing phase. In the designing phase, we are going to design how we are going to implement that given problem. So in the designing phase, we have three types of phase. One is the algorithm, flowchart, and pseudocode. So you can select any one of them for designing the solution to the given problem. And the fourth step is, after designing, we are going to testing the algorithm what we have developed and what we have designed in the third stage. So testing is based upon the two types of efficiency. One is time efficiency and space efficiency. So time means how much time the algorithm is going to run, and the space is how much space that algorithm is occupied. So based upon the efficiency, our objective is we have to run a small amount of time and we should occupy the less space. That is the main objective of any programmer. That is a fourth phase of algorithm. So that is a testing phase. Then fourth, after testing the algorithm only, you are going to implement that algorithm in any programming language. That is the coding part of the my designing phase problem. So that is the fifth phase. That is the coding or implementation is the fifth phase of my development life cycle. So after coding, we are going to do the testing and debugging the program. You are testing the program with the proper input data, and also you are going to debug the program if there is any error in the testing. So that is the sixth stage of my process. So after all doing, we are going to do that documentation and do that some representation. So that is the main thing. So these are all the program development life cycle. First we have to analyze the problem, and task analysis is the second stage, and after we are going to go into the designing phase, that is a prototype, and after we are going to testing that designing phase process, and next is the coding and testing and debugging, and finally you have to document that representation. So this is the program development life cycle. So next we will see what is a problem solving techniques. It is a set of techniques and graphical representation to provide a logic for my problem. So the problem solving techniques provide the logic for my problem. So for any problem, first we have to understand what is the problem statement and how you can going to implement in terms of logical representation. So in the problem solving techniques are implemented several types of tools. First one is an algorithm. So algorithm is nothing but it is a step-by-step procedure to perform a specific task. Is call it as an algorithm. Next one is a flowchart. Flowchart is a pictorial representation of my problem. And the third one is a pseudocode. Pseudocode is the intermediate between my algorithm and programming language. It is a generic way of representing my logical representation without having any syntax representation of my programming language. So this is the three ways of implementing my problem. These are all the tools we are using. That is also used in the designing phase. Now we will see what is an algorithm. In this type we are going to see what is an algorithm. So algorithm is nothing but it is a sequence of steps, sequence of instruction to describe a method for solving a problem. So the several properties of an algorithm means the algorithm is written in the simple language. It should have a starting point and end point, and also the algorithm should conclude with a finite number of steps. So it should be the finite, and also it is should not be unambiguous. It should not be an ambiguous. So it should be unambiguous, and it should derive some result based upon my input. So the qualities of good algorithm is time, memory, and accuracy. So it should consume less time and less memory and provide a better accuracy. This is the qualities of a good algorithm. For example, consider here you are going to print welcome to SNSCT. This is a program. So now we will see how to derive how the logic is derived in the given problem statement. What you are going to do means we are going to print only that statement in the console window. So the algorithm is a step-by-step procedure. The step 1 is start, step 2 is print welcome to SNSCT. No input, no any other output value is not printed. Only you are going to print that statement only in the console window using the printf statement. So print welcome to SNSCT, and finally you are going to stop. So this is the simple way of representation. This is the way of representation of my problem statement, step by step procedure. Next is in the building blocks of algorithm. So the algorithms can be constructed with the four important terms. One is the statements, states, control flow, functions, and these are all the building blocks of an algorithm. So the statements, state, control flow and functions. So this is the main part of my algorithm. So remaining we will see in the next class. Thank you.